Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
Okay, so for this problem, it's asking us to find the angular velocity of a concrete block right after it hits the corner of a table here at point A, and to find the percentage loss of energy caused by the impact. So the first step is to find the velocity of the block, which we can do by setting kinetic energy and potential energy equal to each other, and then just plugging in the values here. So we have V equals square root of 2gh. We're going to use 1 for h since the height here is 12 inches, so it's going to be 1 foot. And then g is just acceleration due to gravity. So we're going to get that v equals 8.02 feet per second. So now the next step is we're going to find inertia using the parallel axis theorem, which is this equation right here. IA is inertia about the point A. IG is inertia about the center mass. M is just the mass, and then D is the distance between these 2 points, A and G. And so we can expand that into this, M over 12 width squared plus h squared, or height. And same thing over here, width over 2 squared plus height over 2 squared. And we know that the width of the block is 32 inches and the height is 24 inches. And we know the mass as well. The weight of the block is given, so we just have to divide the weight by gravity to get mass. And if we plug all those in, we should get that inertia about point A equals 11.14. And so now we can use the conservation of angular momentum down here to set up this equation. And we can use this to find angular velocity, omega. And so we just have to divide IA to the other side. We know V, we know the width, and we know the distance X. And so we can plug all those in again. And we should end up with 1.593 radians per second. And so that's the first part of the problem. We have the angular velocity, but now we also need to find the final kinetic energy, which is given by T2, and the initial kinetic energy, which is given by T1. And we have the value for IA, we have the value for omega, and we have M and V as well. So we can go ahead and just plug in and find both of these. We're going to find that T2 equals 14.1 pounds times feet. And over here, similarly, we're going to have a much larger value, which is 170.8 pounds times feet. And so you'll notice that the initial kinetic energy is much larger than the final kinetic energy. And so the final step now, we just have to plug these in to our equation for loss percentage, which I've written down here. N is what we're looking for. And we just have T1 minus T2 over T1 times 100 to make it a percentage. And we plug in these values we've got here, and we'll find that we lose about 91.7% of the energy due to the collision or the impact from the block falling. So this is our answer for the second part of the problem. And this is our answer for the first part of the problem.